So what is the revolution we're talking about here? I said reading, writing, and revolution. You could say that's my version of math. But what is the revolution here? And of course, we all know the revolution is CRISPR. But I think that the normal acronym, none of those letters have anything to do with the CRISPR technology that we're all enamored of, that we're all fixated on. It is, so I'm going to give you a couple other words that I think better capture what the revolution is. And it has many components, not just nucleases, but the idea of comprehensive data. Biology, or molecular biology, used to be the anecdote, the single gene, single base pair. But now comprehensive data is a possibility and often insisted upon. We have recombination, not just cutting, but actually cutting and splicing and making exactly what you want. We have informatics, we have sequencing, we have pluripotency, that is to say that you can go from a single engineered DNA molecule into a whole organism, plant or an animal. And we have reduced costs, greatly reduced costs, and that's what the next two slides are about. And for some of these things, I know this is a broad audience, some of these pictures will be inappropriate, they will be complex. Just think of them as eye candy, so I'm not even going to explain what I just showed you. But I like the NovaSeq instrument. That's the newest of the next generation sequencing. It's named after my granddaughter, whose name is Nova. Anyway, just kidding. So her name really is Nova. But anyway, we have this exponentially shrinking cost of reading and interpreting your genome. After I had been obsessed with this for a long time. In fact, I've been obsessed with this ever since I left Sung Ho Kim's lab, who's here in the audience, when I was 20-something years old. And shortly thereafter, before that, we couldn't even conceive of the project. But when we finally started delivering it, it looked like it was going to be $3 billion, which is about the price of this tallest building in the world. And then it's come down ever since then. It's been about $1,000 for over a year. And in a certain sense, it will be free soon, in the same sense that that phone has on it free software. Google Maps, they used to charge for it, and now it's free. And in fact, many people in our project get their genome for free. There is, just as I've been impertinent enough to redefine CRISPR, I'm going to be blasphemous enough to say that there is more than one editor in the world. There are 9 editors. And what these molecular machines do is they scan your genome, which for humans is 6 billion base pairs, looking for one place that they like, one 20-mer, 20 ACGs and 200s in a row, that the machine likes, and making either a cut or a recombination at that point. How does it do that? How does it find 1 in 6 billion? Well, the scan head, the place where the action occurs, where that recognition of 20 base pairs out of 6 billion occurs, is either DNA in red or RNA in blue, which is what CRISPR uses, Cas9, or there are 4 of these that use protein to do the recognition. And so you have Watson-Crick base pairs that are doing the scanning for DNA and RNA, and proteins have more complicated, but at this point very well understood rules, and you can dial them up. And so that brings us to the next question. Why is everyone so infatuated with CRISPR? Why do we think that it's an improvement at all? And a lot of people say, well, it's really easy to use and it's low cost, and that's the reason that we have exalted it to such a high status. I will say that maybe, but maybe not, because about the time that we were starting to publish this deluge of CRISPR papers, where the first few had come out, this lovely paper came out from Jin-Soo Kim's lab, where they, with very little fanfare, assembled an alternative to CRISPR nuclease, a so-called TALEN, or for almost all of the protein coding genes, so over 18,000 of them. So it can't have been that hard to do, even though it wasn't CRISPR. I realize it's an anecdote, but there you have it. That was the previous technology, and its day in the sun only lasted about a year. CRISPR has lasted now a whopping 4 years in the sun, and it may last forever. It may be the last editing method. But this is kind of the history of. I could write the same thing for genome sequencing. Very complicated plot of a whole series of replacements. But in this case, it starts with homologous recombination in mammalian cells with Oliver Smithies and Mario Capecchi. And some people ask, who's going to get the Nobel Prize for genome editing? And I say it's already been given to Mario Capecchi and Oliver Smithies. I mean, that's very silly of me to say so. But the point is there is some progress, but there's also a lot of, this is, again, factors of 10 on the y-axis. There's a lot of constancy in the editing efficiency. But I think it's the editing efficiency that is what we are celebrating here with CRISPR. Now, to be a party pooper again, there is, if you're going to be applying CRISPR, especially in a clinical setting where you're treating a large number of human cells simultaneously, if any one of them gets an off-target event, and most drugs have some kind of off-target event, if you have an off-target event with CRISPR and it lands in the middle of a tumor suppressor gene, then you run a risk of getting a tumor. And so you want the off-target, at least in tumor suppressor exons, to be as low as possible. And I'm not going to go through them, but there's a whole bunch of, and this list isn't even give it justice. There's a large number of articles that have improved the specificity of CRISPR, at least in certain contexts. When we talk about some of the exceptional people in the world that are, like, in a certain sense, naturally enhanced, I think of people like Helen Keller and Stephen Hawking, right? So Helen Keller could not hear or see, but nevertheless she was a remarkable individual. She inspired my wife to go to Radcliffe for college. Stephen Hawking inspires me. I will retire when I can move fewer muscles in my body than Stephen could. So what are we talking about? What is it that we're actually concerned about? I think we're mainly concerned about inequitable distribution. It's okay for us to be enhanced relative to our ancestors. We are. I mean, we don't have to worry about smallpox. It's one of the few technologies that's actually equitably distributed through an entire planet because we don't even have to do vaccines anymore. So we don't have to worry about the cost of distributing and getting healthcare workers to find every single village and find the very last person who has smallpox. We're still worrying about that with polio. We missed the last person with polio, and now it's spread around the world again, and we're going to get rid of it again. Just like with smallpox, it didn't happen right away. I would say there are two things that I'm obsessing about recently. One is global warming, and the other is augmentation. We've talked a little bit about augmentation in the last video conference video recording that you did. But global warming is something that strikes me as a very interesting social phenomenon, scientific challenge, because what you have is, from the social side, you've got this case where you've got denialism, which to me is more important. I mean, you have denialism on a bunch of points. You have denial of the Holocaust, you've got denial of evolution. But those aren't things that necessarily, in and of themselves, impact our lives. I mean, it's very heartrending and callous that they deny the Holocaust. But as long as they don't add to that a lot of other racism, nobody's going to get really hurt by it. And evolution, even people in my companies, which work on evolution on a daily basis, like I have a company called Inevolve, which has evolution in its title. I imagine that we could probably populate that company mostly with employees that are creationists, and they would still get the products out. Because you follow a recipe, and even though you're doing evolution, you don't need to believe it, right? Now, maybe the very, very top scientists, it would help if they actually believed in neo-Darwinism or something. But anyway, so that you have this. So those are curious things where people fight about them and have deep feelings about them, but they don't really affect day-to-day life. Global warming is something that could be catastrophic. I mean, you could argue it's in the same category because you can't prove that my life today is worse because of global warming. But it's something where it could be exponential. I mean, the odds are against it, maybe, but we don't really even know how to calculate the odds. It's not like we're playing blackjack or poke or something like that. It's like that there's more carbon in the Arctic tundra than in the entire atmosphere, plus all the rainforests put together. And that carbon, unlike the rainforest where you'd have to burn the rainforest to release it, that carbon goes in the atmosphere as soon as you get melting, and it's already many gigatons per year going up. And so that's something that could spiral out of control. The other thing that I think is problematic socially is the whole idea that it's an inconvenient truth. I think to some extent Gore's phrase is brilliant, but to another extent it's counterproductive, because the people for who it is inconvenient don't want to believe don't want to believe it's inconvenient. They don't want to deal with something that's inconvenient. They don't want to give up their SUVs and their steak meals and so forth. And so what would be better would be to talk about a convenient solution. Whether or not that's the real solution or the best solution, but just talk about it so you get acceptance first. You need acceptance before you can get to the best solution. And the other part that makes acceptance difficult is blame. Is people will say it's not my fault. And that gets confused into it's not anybody's fault. It's none of our faults. It's not anthropocentric. It's not caused by human beings. You could make an argument it's not your fault because you weren't around during the Industrial Revolution. You didn't personally do that much. You're just 1/7 of the problem at most. So you could make an argument that you're not personally, but then expanding that to no human being has had anything to do with it is where things go off the tracks. But it really, the thing that got us into the position of denial was the blame game. It's like, you want everybody to be inconvenienced because it's their fault. And so that's two strikes against you. I don't know if you've read The Righteous Mind, but he makes the point that most people, even people that consider themselves very rational, they're not using a rational argument and then deciding. They're deciding and then using the rational argument to rationalize it. And a lot of what he says sounds obvious once you restate it, but the way he says it and backs it up with social science research, I found very illuminating, if not compelling. And anyway, so I think that's what happens is that the elephant, as he refers to it, the thing that's making your decisions in your life is deciding that this person is telling you that you're responsible for something you don't feel responsible for, and is telling you that you have to sacrifice many things that you don't want to sacrifice. That person is inconvenient, and they're incorrect from your viewpoint, and you're going to ignore them. And the more they insult you and your way of life, the less you're going to listen to them. And then you're going to make a bunch of rationalizations about that. So I think that these are why we have problems. So let's reframe it: is you're not responsible necessarily, but here's an opportunity. Here's an opportunity. Let's say nature caused this global warming, and maybe this global warming could get worse. Let's not even say that it has gotten to a horrible place. I mean, we're at 400 parts per million. Maybe that's too far.
But let's just say that it could get exponentially worse. That risk is very high, because if it keeps going exponential, you'll eventually consume all of the carbon dioxide and all the methane that's right below the surface. And we know there's tons of methane in the cold water and that could be released. And methane is 28 times, by the way, worse global warming gas than carbon dioxide.